The mouth is the beginning of the digestive tract. Chewing breaks the food into the pieces that are more easily digested, while saliva mixes with food to begin the process of breaking it down into a form that your body can absorb and use. The digestive system starts off with the mouth. Located in the throat near the trachea, the esophagus receives food from the mouth when it is being swallowed. By means of a series of muscular contractions called peristalsis, the esophagus delivers food to your stomach. The stomach is a hollow organ or container that holds food while it is being mixed with enzymes that continue the process of breaking down food into a usable form. Cells in the lining of the stomach secrete a strong acid and powerful enzymes that are responsible for the breaking down process. When the contents of the stomach are sufficiently processed, they are released into the small.
The small intestine is a 22-foot long muscular tube that breaks down food using enzymes released by the pancreas and bile from the liver. Peristalsis also is at work in this organ, moving food through and mixing it with digestive secretions from the pancreas and liver. The duodenum is largely responsible for the continuous breaking down process, with the jejunum and ileum mainly responsible for absorption of nutrients into the bloodstream. Contents of the small intestines start out semi-solid and end in a liquid form after passing through the organ. Water, bile, enzymes, and mucus contribute to the change in consistency. Once the nutrients have been absorbed and the leftover food residue liquid has passed through the small intestines, it then moves on to the large intestines. The colon is a 6-foot long muscular tube that connects the small intestines to the rectum. The large intestines is made up of the cecum, the ascending colon, the transverse colon, the descending colon, and the sigmoid colon, which connect to the rectum. The appendix is a small tube attached to the cecum. The large intestines is a highly specialized organ that is responsible for processing waste so that emptying the bowels is easy and convenient. Stool, or waste, left over from the digestive process, is passed to the colon by means of peristalsis, first in a liquid state and ultimately in a solid form. As stool passes through the colon, water is removed. Stool is stored in the sigmoid colon until a mass movement empties it into the rectum once or twice a day. The stool itself is mostly food debris and bacteria. These bacteria perform several useful functions, such as synthesizing various vitamins, processing waste products and food particles, and protecting against harmful bacteria. When the descending colon becomes full of stool or feces, it empties its contents into the rectum to begin the process of elimination.
Here we have Joey eating a cracker. As Joey swallows the cracker, it pushes the cracker into the esophagus, a muscular tube that pushes food and liquid into the stomach. Once swallowing starts, it becomes involuntary and continues under control of the esophagus and brain. As food approaches, the muscle relaxes and lets the food pass. After traveling through the esophagus, the cracker arrives at the stomach. Muscles from the upper part of the stomach relaxes to allow food in, and muscles of the lower part mixes foods and liquids together with digestive juices. The stomach then stores the cracker in liquid, mixes the food and liquid with its digestive juices, and slowly empties the contents, called chyme, into the small intestine. Once the chyme is in the small intestine, it combines bile and other enzymes from the pancreas with digestive food and pushes it to the large intestine. The small intestine walls absorb and diffuse nutrients into the bloodstream. Muscles push waste products into the large intestine. Waste products of the digestion include undigested parts of the food and older cells from the GI tract lining. It absorbs water and any remaining nutrients changes the waste from liquid to stool. The rectum stores stool until it is pushed out by a bowel movement.
Our digestive system is similar to a dog's digestive system. Since dogs are mostly carnivores, they have a much simpler digestive system, as meat is much easier to digest. Both humans and dogs have same organs such as mouths, stomachs, and intestines. However, dogs have more acidic stomachs that take much longer to break down. This makes it easier for dogs to absorb nutrients in the intestines as the food has already been broken down, leading to a smaller intestinal tract, but still able to absorb enough nutrients to survive. Diseases associated with the digestive system. Crohn's disease, a chronic or long-lasting disease that causes inflammation and irritation in your digestive tract. Gallstones, hard particles that develop in the gallbladder. Gallstones can cause sudden pain in the upper right abdomen. This pain, called a gallbladder attack or biliary colic, occurs when gallstones block the ducts of the biliary tract. Short bowel syndrome, a group of problems related to poor absorption of nutrients. People with short bowel syndrome cannot absorb enough water, vitamins, minerals, protein, fat, calories, and other nutrients from food. Peritonitis, inflammation of the lining of the abdominal cavity. Indications of peritonitis are called peritoneal signs: tender abdomen, rebound pain, pain when manual pressure released from examining abdomen, board-like rigidity of abdominal muscles, no bowel sounds, gurgles. The peritoneal membrane is very sensitive to exposure to foreign substances. Contact with blood, bile, urine, pus will cause peritoneal signs. The digestive system works through the muscular system, as muscles provide the ability for food to be pushed through the esophagus and down the GI tract. It also works with the circulatory system to help transfer nutrients from the digestive system to the bloodstream. Similarly, it works with the excretory system, as both filter out the nutrients from each other and dispose of waste and products not needed by the body.
People should eat, on average, 50 grams of protein, 70 grams of fat, 310 grams of carbs, 90 grams of sugar, and 2.3 grams of sodium per day. Foods such as hamburgers and french fries are full of fats and carbs and are grossly over the recommended amount of certain molecules. However, it is not good to completely shun one product, as all of these molecules are necessary for your body to run properly. Eating proteins, grains, fruits, vegetables, and dairy daily, paired with exercise, are able to keep a human body healthy.
Examples of nutritious foods are salmon, which contain beneficial fatty acids, protein, vitamins, and minerals. Blueberries, which contain powerful antioxidant substances and are very nutritious compared to most fruits. Garlic, which is high in vitamin C, B1 and B6, calcium, potassium, copper, manganese, and selenium. The bioactive compounds in it have been known to have disease-fighting properties. Potato, which contain a little of every nutrient needed, very fulfilling, and can contain large amounts of resistant starch.
Examples of non-nutritious foods are white bread. Most commercial breads are made up from refined wheat, which are low in nutrients and leads to rapid spikes in blood sugar. Commercialized fruit juice. Although fruit juice is thought to be good and does contain some antioxidants and vitamin C, they are often too sugary. Processed meat. Observational studies have shown that people who eat processed meats are at higher risk for dangerous diseases, including colon cancer, type 2 diabetes, and heart disease. Processed cheese contains lots of filler ingredients that don't provide nutrients. In the United States and the European Union, both have similarly strict food labels. However, the U.S. bases nutritional information on one recommended serving size, while the European Union is based off the nutrition in 100 grams of a substance. Europe is stricter on the chemicals allowed in foodstuff. For example, there are rarely any artificial dyes, and they also don't inject their cattle with artificial growth hormones. The European Union also requires GMOs to be labeled. In the U.S., it is up to the producer. The U.S. permits use of many chemicals and biotechnology on its food products with not much regulation.